My portion will be about workflow. How do you actually interact with these things? Potential best practices, and hopefully ways to collaborate together so that, as you develop code, it can be done in a group setting. So that's me. I look like that if I look that way. No, nobody got that. As Dr. Nathal said, I've been programming for 15 plus years now. So I've done everything I can to try to figure out how to do it more optimally, quicker, faster. And in the HPC world, I've seen a lot of different ways that people do things, including getting on the machine and writing code there directly in Vim or whatever else, or FTPing it up. There are better ways. So this is the goal for my talk, right? So very simple, 4 things that I want to go through. Just so I know how much time to spend on each, show of hands, who has experience with source control? Okay. What about Python environments? Okay. What about, and I won't spend too much time on this, what about Keras or TensorFlow? And what about SLURM?
Virtually no one but our group.
So I need to spend an equal amount of time on everything. Got it. All right, so first let's get going. Git is, I expected more laughs. Come on, if you guys knew Git, that would be a much better joke. Git is a distributed graph for maintaining files, right? And we won't get into the details of that. It's actually really complicated and really interesting the way it manages to keep versions. All we need to know is that it's about 15 years old. It was created by the guy that made Linux. So it's been battle tested. Actually, he made Git because Linux was a growing project and he needed a way to collaborate with people across the globe. And they could no longer email each other tarballs and files. It's a version control system. So show of hands, who here has written any code ever? Okay, awesome. If you've written code, the first thing that you're going to notice is that you're going to break something eventually, right? Yeah. At some point, something that was working will no longer work. With the version control system, you'll be able to say, okay, it works at this point. I'm going to call that a version. I'm going to commit it. And I no longer have to worry about how do I get back to there. Right? Because if you've broken code too badly and you've never committed it or saved it anywhere, you'll never be able to get back to it. I've been in that place many times. So once you have those older versions, you can quickly go back to it and see what happened. And as you commit things within your Git repository, it creates this documentation, this trail of who did what, when, and why. And the most important thing is you get to code with others. So, and I'll show you practically how it works, but basically, you can think of a branch, right? So with Git, you have your file system in this state, and it continues to move on as you edit files and save files. But you can also branch, right, to test a new feature that you're creating, to fix a bug, to work on a new idea, and then eventually merge it back in. So that's Git. Now let's make it practical. Who's ready? Yeah? No? No one is ready? Okay. Can everyone see the screen?
I told you that live demos are fatal.
Always do it live. So first, everyone should have an account at GitHub, right? Oh, there it is. Make a new repository. Call it mnist. Make it public. And let's even initialize it with a README. So by putting this up on GitHub, everyone has access to it. I can clone it down. I'm going through a lot of the steps super quick. Git clone. Can everyone see that, or should I biggerize it?
Go bigger.
Biggerize it? Okay. So now I have my repository here. So let's go ahead and put a file in here. I have this mnist file that I've stolen. Call it mnist.py. Let's biggerize that as well. So that basically, for those that are not familiar, this is taking a handwriting database of letters and training a network to recognize them. So I'm kind of happy with that. So using Git, I can commit it. Initial mnist file. I hope it works. Nope, I didn't add it. Okay. Push it up. And now it's there on my GitHub. So there's the file that I made. There's the comment. And if I want to see the file, I can see it there. So that's Git in a nutshell. Now if I go to the HPC, here's the wonderful part. I'm working on my local machine. I have this mnist file. I'm doing whatever it is. Maybe I'm doing protein folding, or I'm doing letter recognition, or whatever my challenge is. I'm coding on my machine. But then I can clone the code up here to the HPC. So this, right now, I'm logged into an HPC, actually at Rutgers. And there we have it. There's the file there. So that's Git in less than 2 minutes.
So can you explain the link between Git and GitHub?
Yes, so Git is a protocol. It's a software that will do this versioning and this version control and this adding files, removing files. GitHub is a company, which is now owned by Microsoft, that basically hosts repositories. You don't have to use GitHub. There's many others. There's Bitbucket. You can create your own Git server. There's GitLab is the other one, but GitHub is the biggest and the most well-known. All right, pip and PyPy. When you're coding anything, your goal as a developer is to code as little as humanly possible. Or at least that's been my stated goal. And the way to do that is to find things that other people have done and try to build on top of it. So within Python, there's a tool called pip and a site called PyPy. Pip, anyone know what it stands for? Pip installs packages. And PyPy is the Python package index. So there's 170,000 packages. If you have a problem, somebody has solved it, more often than not.
Yeah, I think that's why Python shines.
Yeah.
Why people moved from MATLAB. Some people moved from MATLAB to Python, or
Not
some people
Chris.
started with. So he will be forced to move. So because again, Python has millions of built-in functions that we love to use and we love not to code again.
Yeah. If you find yourself coding something, the first thing that I do is I say, I bet you someone smarter than me has already done this. So.
Stack Overflow, go to Stack Overflow and find. So these are.
And how about the R? Does the people move from MATLAB to the R? R is more kind of close to the R.
R.
Yeah.
More statistical.
Statistical. Okay.
Yep.
So the problem with Python is that your workflow can be very complicated, right? Because as you're downloading these different packages, there's different versions because people continue to update these packages. You might need version X for project A and version Y for project B. So there's been different solutions that have been built on top of that. The one that I like the best is pipenv. It's the official Python package manager. There's a long history behind it. There used to be a requirements file and so on and so forth. But the beauty of pipenv is you can maintain different versions of a package across different projects, manage your dependencies. So if you do need a package, like let's say pandas, pandas also needs other packages, let's say NumPy and a handful of others. So something like pipenv will keep those cached for you, so you don't have to re-download the same packages over and over again. You can also create and manage virtual environments within pipenv. You might have a case, I think Dan, I guess he left, right? So he's saying that in the RUCC, they have Python version 3.4. On my computer, I have Python version 3.7. Rutgers has Python 3.6. So in my virtual environment, I can create a Python version that'll match whatever it is that I'm trying to accomplish. And for TensorFlow people, there's this constant problem. I think 1.13 doesn't work, or 1.12 doesn't work with Python 3.6, or
3.7.
yeah, something like that. Or 3.7.
Yeah, there will always be things which don't work with each other.
So the goal is to create a virtual environment, which is basically like to put it super low level, like a mini computer almost, with all the different versions that you need of the different software packages. Super easy to install pipenv. You can use pip if you're a Windows person. You can use brew if you're a Mac person, or Python script if you're a Linux or Windows person.
So can we choose the softwares on the VPN, like the one that we?
Yeah, so if you are going to be using NumPy, for example, instead of doing pip install NumPy, you do pipenv install NumPy.
Oh.
And it'll change your life.
One word for the other folks about virtual environment.
Yeah. So, no, I'm not going to say it, I'm going to show it. Okay. This is mostly everything you need to know. It's extremely simple. And I'm disappointed that no one's getting that. One? All right, we got one.
Like, how do you expect them to know?
You guys should be teaching that, I think. That should be in class, right? So common packages. Within machine learning, and different domains have their own package that they'll be using. So it's demo time. We're going to go to virtual environments, and everything. Who's ready? Show of hands. Okay, a little bit more than last time. I'm impressed. A couple people still aren't. All right. So in my little MNIST project, you'll notice that I need Keras, but I don't have Keras. So I can do pipenv install Keras. But since I'm running it on Rutgers, I need Python version 3.6.
Clear it all.
You guys can't see? So here's what happened. First thing it did was create a virtual environment for this project, this MNIST project that I've made. It created a pip file, which I'll show you in a second. It's using the version of Python that I specified, because on my computer I have 7 different versions of Python. I needed 3.6, so it chose 3.6.8. It created a virtual environment and put it in my home folder, and in there, any future files or packages it'll need, it'll keep in that folder. So if I have another project on my computer that's doing CFAR or another problem with a different set of files that it needs, that's been kept completely separate. So that's the virtual environment. The executable that I'll be using for Python is also my virtual environment, right? So when I'm in this project, when I run Python, I'm not going to run the Python of my Mac or that's of Windows. I'll be running a specific Python that's for this virtual environment. And that can matter because you can compile and build Python with different options. Okay, so we have created a pip file, which is called Keras, log file, and we're done there. So let's take a look at the pip file. So this pip file is super simple. It's telling pipenv that we need Python version 3.6. We're installing Keras, and we don't actually care what version. So whatever the latest is. If I cared, I could specify. Now, which Python? Right now, when I run Python, you guys can't see that, can you? If you guys jump in the back, you might be able to. So right now it's running that Python. But if I do pipenv shell, I now go into the virtual machine. I go inside the computer, as it were. So now if I do which Python, I'm running a different Python, right? So before when I ran Python when I was not in my virtual machine, I was just running the generic Python compiler that is in my path. Now that I'm in the virtual machine, I'm running this specific Python.
How about if I have more than one environments?
So I have that set up as well. So it's HPC Workshop. I have another environment set up here. And here, I'm in the HPC Workshop virtual env. So the virtual environment lives with the folder that you're in. Okay, so now that is that demo. Last part is SLURM. Show of hands, SLURM again. Okay, we got like 13th of the class. It used to be called Simple Linux Utility for Resource Management. Now it's just called SLURM. It actually doesn't stand for anything anymore. The point of SLURM is to not be selfish, right? Because everyone wants their job to run all the time, and doesn't matter what anyone else is running. But SLURM tries to be a little bit fair about it, right? So maybe you get an hour, maybe you get an hour. I'll get 2, but that's a separate story. There's 2 modes. There's the interactive, which is blocking, which you should never do. And there's the non-blocking, which is scheduled, which you should always do.
I want to say that's what we have installed in IUCC, right? We have SLURM.
Yeah.
No, but it's not being used. So, yeah,
That's another issue.
yeah, but
We have SLURM.
So ideally, you always have to use SLURM to submit your jobs. It's kind of breaking the light, or it's criminal to use resources directly, run your jobs directly on compute nodes. You cannot do that. It has to go through SLURM.
Are you going to show them how to go through SLURM?
Yeah.
That's what he's.
So there's only 4 commands that you'll need, probably. The first one is the one that Dr. Russell was saying never to use.
But there it
Which
is.
we use, right?
Right. So now who's ready to go through another demo? Less people. How's that possible? Okay. So I am on this HPC here, and I put up a job before for CFAR 10. Right. So I had written this code, stolen this code. And for those of you that don't know what CFAR is, it's this challenge where you have these images and you have to classify what it is, right? So that's a car, that's a dog, that's an ostrich, and there's only 10 classifications of categories in CFAR 10. So this is some code that it's a small neural network that will look at those images and try to classify. Problem is, I can't really run it on my computer. I can, but it will take a very long time, which is why we go to HPCs in the first place, right? So it's going to take the rest of my life if I wait. So the first command, SQ, what's running? So someone, I don't know, is running something. I'm not running anything, so I'm good. Let me run sbatch will schedule my job. And it assigns that ID of 1624. If I want to see what's going on inside my job, it creates this fancy little out file. And you can specify where you want to put it into a Scratch directory or right now in my project directory. And I can watch it if I get bored, right? So it's trying to train, and I'm sitting here watching. I can close out of this because it's just a log and my job continues to run. And if I want proof, there's my job, 1624, that's me, and that's what it's running. And it's been running for 35 seconds so far. And then it's 2 a.m., Dr. Rasul calls me and says, I need the GPUs, stop running your job, so unfortunately I have to cancel my job. Cancel, and it's dead. So that is.
Can you show the asking for? Because that will be very useful for the user to identify which queue you want to submit to.
So if you do sinfo, then you can see. In my case, I specified it there. in my bash file. All right, that's me. That's my time. So, thank you all.